a great metric for where pro and anti-church sentiment exists. And so this is kind of just a bunch of monks reading these manuscripts back in 1400. And the difference is that today we have computers. And so instead of monks, we had these rooms of experts who would read all these documents, and then they would put these sort of document reading ability into a computer. The computer would scale this out using data science techniques, and this would reduce our costs and time to completion. That's the difference between the medieval ages and today. It's not necessarily about the type of analysis that's being done, it's more about the scale. And so we think about this prediction problem. As a data scientist, you think, why are we trying to predict as a function of X? So, Brian put these up here. We're trying to take these inputs and predict these contract provisions. I would switch that. I would say that instead, we're trying to predict risk of loss as a function of the unstructured text data that are in contracts. So these could be provisions, sections, other types of things, but we really want to predict that risk as a function of the unstructured text data. One question that we might substantively be interested in would be, what would the risk be if we changed this provision? So that's one causal question we might be interested in. Another one might be, if we used, or if we want to achieve our optimal risk, what provisions would we want to put into the contract to achieve that optimal risk? So those are two questions that we can answer using these techniques. And so a little bit about unstructured and structured data. I know there's a lot of data scientists in the room, but I think this is useful for the people who aren't familiar with what unstructured data is. Unstructured data is sort of like a pile of Legos. It's a bunch of text data. It's about 80% of the world's data available today. And all this data, we need a way to reassemble this into something that kind of could fit in like a CSV spreadsheet, something that makes sense. And so the techniques of data science and NLP as applied to unstructured data are to take this pile of Legos and build it back into a building that actually makes sense. And that's pretty much what we're doing. The big question is, what methods do we use to structure this? So there's, of course, two methods. Automated content analysis can be done through supervised learning. So in the supervised learning context, we're trying to take all these contracts. Some are good, some are bad, some are suboptimal. We put those into a model, and then we use the model to predict what unobserved, unstructured data might predict for that contract. So we have a new contract. We haven't had an expert read it. We use the model. We predict what it might actually be. Now, the big question is, who's coding for these? Who are the experts that are producing these codes on these documents? And how can we quantify risk of loss or other types of risks that are associated with contracts? We might, if we can't get these codes, so if we don't know who's coding for these, we might go to an unstructured, sort of unsupervised learning framework. And these algorithms will take these documents. It'll look for kind of, commonalities across certain documents, and it'll produce clusters. So, this might be the good cluster, this might be the bad cluster, this might be the sort of suboptimal cluster. But the big question is then again, what do the experts say about those clusters? Are those clusters actually meaningful, and can we use those to achieve some sort of business, actually some sort of business outcome that's more optimal? So when you think about the feature engineering that needs to go into this is for the data scientists in the room, the big question is, how do we pick those right features? How do we pick the right contracts or language or provisions that need to go into that contract to predict risk? We might be interested in theoretically driven features, and so I'll talk a little bit about how red lines might help us indicate that. We might be interested in informative features by collapsing over all this sparse data. That's the big problem of NLP, is collapsing information over sparse data. And so, a few feature engineering tricks for legal language. Legal language is very specific. We might be interested in using part of speech tagging to produce better features. We might be interested in lexical diversity. So there's a little bit of research that shows that people who are trying to obfuscate things in contracts actually use more complex language. And so we might be looking for something like that to predict risk. But the big thing that's here, and I think this is the interesting thing about the data set, is the fact that we have how the negotiated language has evolved over time as part of a red line. So if you don't know what a red line is, if you think about track changes in Microsoft Word, this is basically you send a document that you've written, somebody else changes something, it tracks what they changed, they send it back to you, and you can see what the differences actually are. Now, if we can take those, treat them as a time series of unstructured data, then we can see how the language has evolved over time and use machine learning methods to identify salient contract provisions and other sorts of legal things that I'm not too familiar with, and predict risk as a function of those time series features. When we think about reducing the dimensionality of this giant feature matrix, because we take all these features out, we take all this unstructured data, we blow this into a giant matrix, how do we actually reduce that down to the things that matter? We have supervised learning techniques and a few unsupervised learning techniques, but the one I want to really highlight here is the ability to use a lasso or maybe a multinomial inverse regression to be able to optimize the features that we select with respect to the risk that's associated with those contracts. So those are the types of features and contract provisions that we'll like to be choosing. Now, this wouldn't be an NLP talk in 2018 unless we didn't talk about word embeddings. And so I want to just use a quick application of word embeddings to something like this. And so something that's really cool about word embeddings is that you can cluster things that are similar. And so if we're looking for sort of provisions and other types of language that are similar to each other, we can look at we can use the word embeddings for those sections or those words to cluster out and say, oh, okay, here's a cluster of language that looks similar that people might not otherwise really care about. Kind of like this idea that you might use a different type of language, but the other party won't really care. However, that language might actually be associated with lower risk. And so if you use these clusters, you can optimize the risk by choosing the best provision or word from within